Well, hello everybody. So today we'll be talking about something called the second derivative. And I'll make several videos about this, but as far as this video goes, I'll just talk about the concept, okay? Because in math, I guess you could say there's two sides to everything. There's the concept or what the thing is, and then there's the method for calculating, okay? And those are two different things most of the time, okay? So here, yes, the concept, I'll tell you what the second derivative is, how we think about it, how we think about its meaning, and that sort of stuff. In another video, I'll focus on how you can calculate the second derivative, but for now, the short answer is you just repeat the derivative process indefinitely. You can find the second derivative, the third derivative, the fourth derivative. You can keep going as long as there's another answer, okay? All right, so that's a little bit of an introduction for now. Let's do this, okay? I want to talk about where we started with all this up to where we are right now. So where we start when we do, say, anything algebra or higher is with a function, f of x. So f of x is our notation, our symbol for a function. You could say it's a function, you could say it's a curve. Sometimes we say curve if we want to emphasize the graph of the function. So I'll use those terms interchangeably, okay? You've heard the saying with the coronavirus that at one time we were told we needed to flatten the curve, okay? And that curve was the graph of infections over time, okay? So people talk about curves in all kinds of mathematical settings. All right, f prime of x, the f with an apostrophe like that, okay? That is the first derivative, or so far what we've just called the derivative. Now, I want to make this video about the concept of the second derivative. So I'm going to review the concepts all the way along, right? So you've got the function, the curve, you've got the derivative, and let me tell you or remind you what the first derivative tells you, how you can interpret it and all that. One thing is it tells you the slope of this original function or curve at any desired point. That's one way to think about it. Sometimes we do think of it that way. But another equivalent way to think about it is that the first derivative tells you how y and x change together, okay? So you can think that the function f of x tells you what y is if you know what x is. That's the function, that's its job. The derivative says if x changes, how does y change? All right, sometimes the first derivative is called the instantaneous rate of change for that reason. It tells you how the variables change together. And the only fine print with the first derivative is that, yes, it does tell you the change in y over the change in x, but the change in x is very small in the context of the derivative. Okay, very, very, very small. Think of it that way. All right, so now we've got our first derivative. What does the second derivative do? Well, we just repeat the process to get the second or third derivative. So since the first derivative tells you how the variables in the original function change together, then the second derivative tells you how the variables in the first derivative change together. So you could think of the second derivative like this. You could say it tells you the change in f prime over the change in x, because x is the one common independent variable throughout all these functions, all right? So the second derivative tells you how the derivative is changing with respect to x, how the derivative and x change together. Now that might be a little bit hard to think about at first, so I want to think of it this way, okay? So let's see, derivative tells you the slope of the curve. All right, so think of it like this. Here's a curve in blue right here, okay? F of x is equal to a curve. And I've indicated several points on the curve, all right? And here I might say f prime is -1, meaning that, the curve is sloping downward at about a slope, a rise over run of -1, okay? So, all right, if I say that, if I say the slope or the derivative was -1, I'm saying that spot on the curve It's like for every 1 unit you go to the right, you go 1 unit down. All right. Now, as we go along here, I see that the curve is still sloping downward. The slope or the derivative is still negative, but it's flattening out. And then at the bottom, it's horizontal, where the derivative is 0. Okay. And then here, from here to here, the curve begins to rise or slope upward. And that maybe at this point, the derivative is 1. All right, so I mention all that and I label my curve that way to say that, well, what do we mean when we say that the derivative is changing? Well, over this section of this curve right here, the derivative is getting bigger, all right? Okay, so that's how we might think of this definition of the second derivative, the change in the slope of the curve, the change in f prime over the change in x. All right, so if the second derivative is positive, what that would mean is over some small section of the curve, the derivative is actually getting bigger. All right, so all throughout this region, the second derivative is positive. Now we have a term for that. We say that this portion of the curve where the second derivative is positive, where f prime is actually becoming a larger and larger number, is concave up. Okay, I'll say more about that in another video, but for now you make all the associations in the picture. If the second derivative is positive, the curve is getting steeper from left to right, and the curve is said to be concave up. All right. So let's talk about, I guess, the alternate way that we could have this work out with the second derivative being the change in the derivative over the change in x. The derivative might be changing in a way that it's getting smaller. Okay, so here I drew another small section of a curve, and I've labeled various points on it with a pattern that f prime is getting smaller. So look, as you go left to right on this curve, here f prime is 1, then f prime is 0, f prime is -1, f prime is -2, right? So here the curve is sloped upward very slightly with a slope of 1. Here it's flat or horizontal with a slope of 0. And then it gets steeper and steeper downhill. The slope is -1, then it's -2. Okay, that'd be an example of the change in the derivative being such that it is becoming a smaller and smaller number. So in that case, the second derivative is less than 0 or negative. All right, so the associations are that if the second derivative is less than 0, if it's a negative number, that means that the first derivative or the slope of the curve is getting smaller and the shape of the curve is said to be concave down. All right. Okay, so those are the associations that I want to make with this meaning for our second derivative. Now let's do a problem where we can try to tie all this together. So let's do this. Let's say we have some function v of t, which tracks the value of a commodity over time. All right. And suppose that v of t is rising faster and faster. So not just that it's getting bigger, but it's getting bigger in greater and greater ways. So here's what that might mean. I want to imagine some sample numbers, okay? That where like in this curve right here, this is the curve v of t, and that means that the x-coordinate will be time and the y-coordinate will be the value of the commodity. And these are just really simple numbers, okay? So what would it mean if, like, say, the value of the commodity was rising faster and faster? Well, it might mean something like this. So here, time goes from 1 to 2, and the value goes from 1 to 2. So the value of the commodity rose by 1 when time also rose by 1. Okay? Now, in this section of the curve, when I go from this point to this point, time went from 2 to 3, so it rose by 1. But the value of the commodity rose from 2 to 4, so it rose by 2. So you see how here the time increase is 1, and here between these 2 points, the time increase is also 1. But also between these 2 points versus these 2 points, the value increase is 1 here, where here the value increase is by 2. Okay, so that's what it means if the value is rising faster and faster. Each jump is higher than the one that came before it. Now, all right, so that means that what? What in the context of what we said back here, what would that mean? Well, okay, so a curve would have to look like this. It'd have to be getting steeper as I went from left to right on it. And that would mean that v prime, the slope of the curve, was getting larger. Okay? And then we said that if that's true, if the slope of the curve is getting larger, then that means the second derivative is positive. All right? Okay. So, well, all right, I can make that as a statement about what the first derivative and the second derivative are. The question is, what can be said of the first and second derivative? Well, I can't give you numbers, all right, because there were no numbers given in the question. I just gave these as a sample to help us imagine the scenario. But I can say this: if v of t is rising faster and faster, it must be true that v prime of t is getting larger and v double prime of t is positive. Okay, so let's add one more thing to this in case our question says, you know, just like tell me what are v prime positive or negative. Okay, well, both of them will be positive in this case. All right, so this is a quick video to get our associations with the second derivative correctly. I want to run through it real quick and just leave you with it. Second derivative is positive, means the derivative is getting bigger. That might mean something like this. The curve is getting steeper. We call that concave up. If the second derivative is negative, the first derivative or slope of the curve is getting smaller. And that might look something like this. And we also call that concave down. All right, so in the next video, we'll talk about the process. How do you calculate the second derivative? And so on. How do you use the rules? All of that sort of thing. And we may use the concepts occasionally. And if we do, we'll come back to what's in this video to use it.